Okay, let's try that again. Hello everybody. GeoDroid John here. You should be seeing my desktop and my screen here. I'm going to go ahead and change some settings here because I screwed up the last one. Let's go ahead and change this back to private until I can figure out what the heck happened there. Let's go to my live stream. I'm trying to do some live stream. I tried to capture desktop audio and it just says was not working. So we'll see what's going on here. It seems to be fine now. Let me turn my audio on. I don't want to hear myself repeating over and over and over again. Alright, looks like 3 people are watching. I'm going to go into my computer down. Okay, last time I was having video or audio problems where there's no volume. Now I'm having audio problems where there is too much voice, like it was repeating over itself. So hello everybody in the comments. What I think YouTube. Hey, Ron Floyd back again. I'm going to go ahead and go back to my desktop. And we're going to talk about the video. Are we still good here? Okay. Let me know in the comments. I do have my little display screen up here. I will be able to keep an eye on the chat. Where am I going to put this? Let's put this right here. Alright, so today we are going to be working on the Ironman project. This is going to be a Ironman project hang. So let me exit this. Let me just go back to the way it was. Z, 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 Z. Okay. Get rid of that wireframe. Tonight we're going to be slicing up, dicing, and trying to print out this freaking Ironman helmet from Nico Industries. Let's go ahead and shoot over to Nico Industries. This is his website. This guy's doing a great job. He's got a bunch of cool files. Good for him for knowing how to actually 3D model. And we have all kinds of cosplay stuff. He's definitely an Ironman fan. And tonight we're going to be working on this project right here. Go over there to his if you want to follow along and learn how I slice up these models. I have printed this Ironman helmet, or a few of them up for my local library. So let's go ahead and do that tonight. No today in 3D. The news is really slow today. So let's go ahead and head over there to that. And we got 5 people watching. Welcome to everybody, including myself. I'm probably counting myself here, but you know, we're just here to hang out and have a good time. So we do have this Ironman mask and helmet. Let's go ahead and delete that helmet. This mask, we'll come back to that mask later in another live stream. So here we have the Ironman helmet. And the goal is to get this on our head in one print using the minimum amount of support material as possible. So here we go. We're going to go ahead and show you what you shouldn't do and what you should try to do when you're making a large print. Most people, when they want to print something, they're going to make it in the orientation that they are trying to print it. Oh, let me fix that again. If you're not using Simplify 3D, you follow along in the steps that would work for your slicer. This is Simplify 3D. It's a great little product. It's hosting software and slicer all in one. Very well supported. Every machine I've had up for the last couple of years has used this. So this is the orientation most people would think you'd want to start when you're setting up a 3D print because that's the way you'd wear it. That's not always the way you want to do things. You actually might want to actually do it so it fastest print time. Although my opinion on this is slow is smooth and smooth is fast. Make it really good. If that means you have to go very slow, then so be it. That's not so bad. Minimum amount of support material possible. 0 if you can get to it, because it just slows down the print. And then and if you have to, do it on an area that doesn't have a lot of surface area, because you don't want the support material to actually screw it up. How you guys doing out there? Okay, so let me show you the way I would like to make this. And we're going to flip this over to wireframe mode. Oh, that's not what I wanted. We're going to go to wireframe mode. And we're going to look for some clues here on the top, because we're going to print this upside down. Let me explain to you why we might want to print this upside down. Because if you just enable automatic supports, this is what's going to happen. Look at all that support material that's going to be on the bottom there. We don't want that much. So what we're going to let's see the print time, and hopefully this won't crash my PC. It might. It takes a long time. While we're doing that, let's go ahead and zoom on over to my Tron XY to see what all these. I can just use hotkeys, boy. So this is the Tron XY. It's currently printing right now. You can barely even hear it. And last night I printed up, I can't really separate this stuff, these 3 pieces here. This small disc that goes on the inside, I printed that part, and then this larger ring. This ring is actually supposed to be the white part of the reactor, so I'm actually supposed to be using that to do it. So, but it does have a spot for LEDs in the back, and the base is what's printing out now, and you're supposed to be able to actually wear it on your chest. So that's what's printing out right now. And I will reprint that in white, and I'll probably make a white and red one and a red and white version to balance off each other. So that's the part of the project, and you do see in the background there we do have the little Ironman set up. Okay, yeah, so that would go right here. It looks pretty cool. I'm going to go ahead and grab that. It's supposed to be wearable, but I will print this out in white and put some LEDs. I don't know anything about electronics or anything, so that'll be a learning curve for me. Just snaps right in. See it snap right in. Boom. Looks really cool. I'm sure if somebody out there is good at painting, you can make it look like the wires and everything that comes along with it. I would love to make a great prop of the thing out of metal. That'd be really cool. So we're back over here on the desktop. You can see that it has decided that to make this model at 0.2 at the speeds I've selected, it would take 76 hours, a little over 3 days. And in reality, I would bump that up by about 25%. So it probably more like 100 hours or 90 hours or so, because all of the support material. I wish it would tell you how long it would spend doing each type of feature that it's doing, like gaps, blah, blah, blah. So that way you can kind of trim down the fat. All right, so give me your best estimation in the chat. How fast do you think I can get this down to? What's the minimum print time you think I can get? So place your bets now, and we'll go through this right now. Okay, let's exit preview mode. And we'll get rid of all of this stuff. We'll remove all the support structures. Now I'm going to do some tricks here. I want this thing to be as big as possible, so I'm going to rotate it 45 degrees just to see how big I can get it here. And then I'm going to scale. If you go over here to scale to maximum size, and it goes to 105.23%. Are we still live? Yep, looks like we are live. Okay. You guys just listening? I don't mind. But place your bets. Okay. So what I'm trying to do here is I want to flip it upside down so I can print the least amount of material possible. So I'm going to try to put it right on the tip of that, right in the middle. So you can see the seam here. I'm going to zoom in. It looks like this is the seam. So I'm going to hit Control L. And that is for Simplify 3D, I think, exclusively. I'm going to click on that little triangle right there, and it's going to lay that part down on the print bed. It's going to place that one triangle I selected flat on the print surface. Now let's take a look at the support material and see what that comes up with. I'm trying different tactics out here. Generate. Okay, so we have a lot more around the outside, around the chin area, but almost none on the inside, which is really cool. That's a really great. If you have confidence in your support material, that might actually work. Let's take a look and see how long that would take. 60 hours. Ron says I can get it down to 60 hours. Okay, I think I'll get it down to less than that. Let's try. So it's slicing and dicing. It's calculating that infill. This is one of the fastest slicers I've ever used. Other slicers like Cura, how long do you think it would take Cura something like this to slice something up? It's a giant STL. Okay, here goes. Here goes. Boom, 48 hours. Already beat it, Floyd. God, I already beat your guess. Already got it down to 48 hours. So that is just with one little change of rotation with the same, same rules for support material locked in. Now you also have to think about the strength of the product when it's done printing. The lines are going to go in that direction. So you want to make sure that, okay, when I print this, is it going to look good in that orientation? And it might not always look good. So you have to think about finishing and sanding and all that stuff. So, this is good. We can save this. All right. I want to rotate this a little bit more, just because I want to get maximum. I'm going to draw this line out, and I want to get maximum scale. I want to get this thing as big as possible. So let's go ahead and Verify that we're there. What's it say we're at? 93. Let's go to 90. There we go. Okay, now let's try that. We want to get this as big as possible. Scale to maximum size. And we're up to 100.92. So that's smaller than the last one. So it's a little bit smaller, so it only hits one of the criteria, which is quick. But now it's smaller than the original criteria we set, which is 105. We got to 105 before. Okay, so let's try another tactic. Let's take a look at different things differently. Let's go ahead and assume, yeah, we're going to have some support material. Let's clear all these supports. Something that can also be done when you're designing 3D prints is actually designing it with support material built into it. So the STL includes support material. You don't see that a lot of nowadays. Nico, if you could take some criticisms, I really don't care what the inside of this helmet looks like. I don't need the ear cups to have this much rigid detail. I would love for it to just be smooth on the inside. That would make 3D printing it a whole lot easier. I wouldn't have to worry about overhangs on the ear cups or anything like that. If you just make all this smooth, then it would be a lot easier to 3D print. So when you're making 3D prints, I would like you to think about designing it with support in mind. So let's go ahead and try something completely different. Let's go ahead and reset this to 0. Okay, negative 40. Let's do 45. Just because I want it back to center. Okay, I want it. Yeah, that's close enough. Okay. All right, that's where I want it, like that. Okay, now we're trying to make it larger than 105% in less than 48 hours print time. So let's see what we can do here. I'm going to rotate this. Wrong way. To negative 135. Negative 180. Let's go negative 180. Center and arrange. Okay. Alright, that's standing straight up. Now the problem I have with vertical prints, they take a lot longer just because they have to take so much more infill to get to the top. So let's try... Let's look at the wireframe again. Not that. Keep doing that. Wireframe. What's this button do? Show normals. Okay. Anyways, let's look at the wireframe again. And let's put it on the seam right here in the middle. Oh my god. Oh my gosh. Let's put it right there. Okay, so Control L. Place it right there on that one. Now why would I do that? Look at that. That's a very tall print. Okay, the reason I think I would do this is because I would have very little support material in the back here. I would obviously have a lot of support material here, but I think I could almost get away with it. Yeah. Let's see what that looks like. Let's add some support material. Only for the lower chin, and it only goes on the inside. I can get on board with that. I can dig that. All right, now let's rotate this. What's 39? Okay, Google. What's 39.36 plus 45? 84.36. Perfect. Thank you, Google. Now we're going to try to scale it again. Scale to maximum size. Let's see what we finally got. 122% of normal volume. That's great. That's probably the biggest I'll ever make this freaking helmet. That's a good size to start with. That way you can have different sizes and you know what the biggest you can start with. When I'm building big projects, I want to be able to start with projects on the biggest item first. That way I know if there's any problems, I can work from there. I can scale down from there. If you start with a project and you make just the faceplate and then you print the helmet at the same scale and you put it all together and realize it doesn't fit, you have to go back and start all over again. So start with the largest part, the part that needs to be fitted first, and then go back. Okay, so let's take some bets. How long will this take? This is 365 millimeters tall. It's about 15 millimeters from the top of my Z. Ooh, it's kind of scary, right? It's kind of scary. You notice the bottom here? And we'll go into some things to actually make this print even faster on the bottom and actually give it a good quality. But right now let's just work with the simple rules that we've dictated. And you know, I'm going to go ahead and cheat here. I'm just going to remove some of these silly little onesies, twosies. I think that, I mean, I'm not worried about that much support material right there. You want to look for these onesies, twosies. Like, do you really mind if that's a little bit overhang? Probably not. So we're going to go ahead and remove that. And it is a good idea between these files between these sets. It's just to save these as different modes. That way you can come back to them. So we'll save this file, save factory file as helmet rotated up, chin support. Okay. Let's see what happens when we flip this and push this through the slicer. Okay, it saved it. Prepare to print. The slicing. We're slicing. Let's check our YouTube. Got 5 people still here. Hello. All right. Slicing, slicing. Let's check on that 3D printer. Actually, I don't need to touch this. I need to learn how to get away from touching it. Let's go to. Are we on 4? There is a Tron XY. It's still working. Nice and quietly, just chugging away. Doing what's got to do. Okay, let's go back and check on 2. Check on 2. Yeah, that's the right button. It's still slicing. Oh, I think we might have a failure here. It's taken a long time. I've noticed that the higher the Z height, the longer it takes to make something. So the lower is easier. Can be kind of a pain in the butt. But it seems to be working its way through there. Man, the stress of being on a live stream, I'll tell you what. Sometimes I've left these alone for like half an hour, come back and it works. But if it doesn't, sometimes just moving it a few degrees. Let's see if it will cancel. Man, I wonder what is powering this. You think it's all memory and RAM? You know, it's all RAM, right? Or processing power. What do you guys out there think pushes your 3D models? I'm glad I saved this, because if I have to close this and come back, we're going to have problems. Let's open a factory file. I think I have one of these saved for the library. Oh, not responding. Oh, man. All right, let's go ahead and kill it. Well, we'll kill that, and we'll come back to it. Let's go to 3. Go to Task Manager. We'll go ahead and kill that. Man, that sucked. You can see live right there what some of the problems is. I have that same problem when I'm doing video editing. That's probably part of the reason I started getting away from editing videos on my PC, is because it's just so slow. I thought I built a good computer, but you know, running these CAD programs, they can be really, really tasking on the CPU and the memory. Okay, so I've killed that app. I'm coming back. I'm going to try to reload it up. Let's go to open. I'm trying to find that helmet again. I hope you guys have all your things, all your files well categorized in individual files like I do. It's just kind of want it perfect. Modified May. Oh, where did I save it? No. Where did I save it to? I lost it. Okay, I have to search for it now. Man, that sucks. Up, chin. I didn't notice where I saved it. Master STL. I saved it under guns for some reason. Why did I save it under guns? Let's go to cut. Let's cut that open. Don't you hate when you put a file in the wrong spot? Alright, I know you guys can't see this. I just really don't want you guys seeing my desktop and all that stuff. So, Ironman, New Century Ironman. Alright, V. Okay, let's open that bad boy up. Now I'll bring you guys back. Let's go to 2. Alright, we're back. Let's go to number 2 and we'll look at how to open this up. Let's go to open. No, we don't care about that. We're going to go to costumes, Marvel, Iron Man, New Century helmet. And I do have 2 of them here. One from May and one from right now. We might go back and revisit that one to see how I did it. What the fuck? I think I lost the STL for this. That's why it's doing this. My God! It didn't bring the STL with it. What the heck? Alright, we'll just do it really quick. We'll do another one. I love navigating through all of my files all over again. Let's go to costumes, Marvel, Iron Man, New Century helmet. Where's it at? Helmet, rotated. Would be that one. Yeah, that'll work. Okay. Let's get rid of this. Alright, that's already pretty much in the orientation I was going to use anyway, so let's just use that one. And then we're going to rotate this 45 degrees. Give us the biggest possible print we can make. Let's see if we get 122%. Let's go to scale to maximum. 118, that's close enough. I'm not sure what I did to make it larger last time. I think this chin was a little bit more over there. It shouldn't really matter, but let's add some support material. Let's give this, my machine's pretty good. We'll give it a generous 50 degrees. Generate those automatic supports. Oh, and it forgot something. From everywhere. Okay. So there we go. That's what it looks like without any cleanup at all. Let's do prepare to print. Okay, come on. You got this. We got this, right? We're going to slice those models. Come on. What you got for me tonight? Oh, big chunk of it. Looking for overhangs. Okay, let's see what else we got here. Thanks, Lydia. I know you're out there, Mrs. LE 3D Printing. She's on the Twitter. If you're looking to get social with me, I'm on Twitter at Mr. John Ecker or Print from SD 3D. So it's initializing preview data. Let's wait for that. We're almost there. I'm just checking out the CR10 while we're doing this. Go ahead and take a look at the CR10. I mean the Tron XY. Okay. So I do have a preview of it. Let's go ahead and take a look. It says 79 hours. It's that Z that really screws you up. The Z height. Huh. Man, oh man. Okay, so it looks like we're going to be going from the bottom up the way we initially had decided on the second pass. We're going to go ahead and change it. We're going to go ahead and remove all this stuff, remove all this. We're going to clear all supports. And we're going to go with this one. This path of actually just slicing it right here on one of these triangles, close enough. Control L. I wish you can select 2 so it can select just the line or something. But boom. That's close enough. Center and arrange. Oh, see, now it's too big for the build area. We're going to go to scale to maximum size. Center and arrange. Now I feel like if I were to raise this up at all, that would actually save a lot of support material. Let's see if this is going to give me any support material. What I don't want to do is have support material in the back. I want to minimize the amount of support material back there. So I'm going to go ahead and, oh man. So let's go ahead and rotate this back the normal way, just because it's going to be a pain in the butt. That looks fine. Okay. Looks straight. That looks pretty straight. Okay, so let's rotate this away. X rotation, wrong. Y rotation. Good, that's what we want. So, let's do some figuring out here. The further back it goes, the smaller it gets. Let's generate some. Okay, that's a lot less support material. I can get on board with that. Okay. And then we're going to go ahead and center and arrange. Oh, it won't do it. All right. So let's try taking 45 off of that. So 100 is 20. 102 is 20. Public math. Okay, Google. What's 122.17 minus 45? 77.17. I don't know why it keeps doing that. Okay, center and arrange. And then we're going to see if we can get this even bigger. Oh, what's it at right now? 104. 104 is fine, but I feel like we can get this bigger. Let's go to scale to maximum size. 105. So my theory is, hypothesis, is that either the closer to the chin, I place the chin to the print surface, or the higher up. If it's not just right there, I can actually make it as big as possible. That's my theory. What do you guys think? Any suggestions from the crowd? What do you guys think out there? Let's work on this puzzle together. I'd love to be able to print it without any support material. Tilt it up or tilt it down? What do you guys think? You know what? I want to tilt it up. Okay, so let's tilt this bad boy back up. Okay, I'm going to go till that part is just flat. Alright. And then we're going to take this back off. 77. Center and arrange. Gives us a little bit more leeway here. And go ahead and generate support structures. Alright, much taller print. It's only 236 millimeters tall. No support material on the inside, it doesn't look like. Let's go from normal, generate a little bit on the inside. Like I said though, I really don't care about the inside. I really, really don't. That's a lot of support material coming off the chin there. Interesting puzzles we have here. Alright, let's do a scale. 111, I can do that. That might be better. That might be the good compromise here for time. Okay, so let's check it out and want to place your comments, your bets in the comments. Let's see what we got. Let's check on that Tron XY. It's looking good. Let's do the infill. I think I left the infill at like 35% for some reason. Shouldn't have done that. But you can't even notice it's printing over there in the corner. Alright, looks like it's done. Let's go back. we're back to 78 hours on the inside here. That's a lot. 78 hours. So it takes a little bit of power here to turn this around. Okay. So like I said, I don't need support material necessarily on the inside. I'm not concerned about the interior quality. So let's go ahead and get crazy, and we're going to remove all supports from build platform only. Generate. Oh, also we want to give it a 50-degree overhang. Gives us even less support material. So nothing on the inside, only on the outside. Prepare to print. We're moving just the inside support material. How long do you guys think it will take? Slicing, dicing. Calculating. Here we go. Almost there. It's going much faster for this pass. Here comes the preview. Anything within the 60-hour window, I think, is acceptable. 60 hours is fine. I mean, also you know, just take your time. Let it do its thing. 67 hours. So we're getting closer. You can tell right there that that's a problem. Now this is my theory. Tell me guys what you think about this. STLs that are designed to fill in the space where a lot of support material would normally be needed. So something like a vase that at the top has a raft, and then you can print from the top. So use the least amount of possible material to fill up that crevice. So imagine like a dome inside of a helmet that is all spiral, right? Or it's just a perimeter and it works its way up, and there's almost nothing on the inside. It's pretty much the shape of your head, and then it fills inside the helmet, and then you don't need that much support material to hold it all up. So basically, STLs, files are designed to help you reduce the amount of infill you use. So think about like triangles, wedges, things with nice overhangs that don't need support material that print right alongside. That might be something that we can work on. Okay, so I think this is going to be the best solution for us right now. Let's try to reduce that even further. So let's look at our print settings here. And we are at 0.2 layer heights. That is pretty standard. But you can print up to 2.4 or 2.8. I have read somewhere that the magic number for the CR10 Z lead screw is a 0.04. So multiples of that gives you 20, 24, 28, and even 32, because you have a 0.4 nozzle. But we don't want to go higher than 0.28 normally. Top layers with we'll tweak that in a moment. I'll show you what that can do. You really don't notice you need to change that until you've already printed this out once. So we're also going to go and check out, okay, first layer height, all that stuff should be the same. Infill, we're going to reduce the infill to about 10%, and we're going to do something else to help. And it will lower the time, and then I'll raise it right back up. Support material. Now this is where we can really save a lot of time. We're going to cut this down to like 15%. Extra inflation distance, we're going to give it the least amount possible. Support base layers, you want to keep that because we do have a very tall towers here of support material. Dense support layers, that means how thick, like the ones that right before they interact, they become thick. I'd leave the rest of these normal. And the temperature, keep that whatever you do as highest as you can print at the same time. Cooling, G-code's fine. Scripts are fine. Speeds, this is where we're going to save a lot of time. So what I've discovered on my CR10 is that if I go a constant speed, it actually prints much, much better. What I mean by constant speed is that no feature gets printed slower than any other feature. So what I'm going to do is I'm going to go ahead and plug in 70, 100%, 100%, 100%, and then except for the Z-axis movement. So everything gets printed at the same speed. You see I already have it dialed in right there. That way, it doesn't have to slow down. The molten thing doesn't have to do it all. You don't have to worry about the melt not working. So that's what I would do. So increase the speed to 70. We could probably go to 100, probably. Print that. Slice to 3D. You guys just out there listening? Spying on me? Not saying anything? Oh, I don't know why this isn't updating. Huh. Interesting. Oh, Ron Floyd. Okay. Tilt to where the chin and the back are level. I think I did that without realizing it. Yeah, pretty much. The back and chin are level. Maybe the tip of the chin and the back of the head. Okay. For some reason, it wasn't pulling up right here on my screen, but when I clicked on it, I was able to see it right there. All right. Let's see. So, is it still slicing and dicing? No, we're at 28 hours. Oh my God, we did it. We did it, people. We reduced it by under 30 hours within one print. And I could still go in there and I can still clean up the STLs. I can clean up all these little hairs or whatever. The inside might look like garbage. This might be a draft, honestly. Like, this is draft quality. But if you had a bigger nozzle, like the 0.5 nozzle, you could probably go even thicker. And the thicker parts, the thicker beads, believe it or not, give you a better weld to the plastic. It gives you stronger parts. So don't think because you're going so like really thin that you're getting better adhesion. It's an easier part to rip apart. So don't be afraid to print thick and wide. Those are actually very strong parts. Print as thick as you can practically print for that device. So that's good to know. We got it under 30 hours. I might just go ahead and set this up. I don't really trust my CR10 here because this new house is known to actually have power outages. I might just take this to the library and where I've done a lot of my long prints and set up a webcam for it. So it's going to cost me about $40 just to make that. So that's been tonight's Ironman live build. I think that's a cool little print. I might actually just go ahead and throw this on there. But you can see what we're going to go over next time, and you won't notice this until you actually make this, is that you can see, you go down the bottom, you'll be able to see how thick or how sparse the first layers will be. Come on, buddy. So look at that first layer. That's a disc, right? And then the next layer is going to be so much wider. So what we're going to go over, how to split processes and actually make this first few millimeters very fine, like 0.16, and then as it passes that layer, because you're having basically concentric rings that go out, you want to reduce the distance between those rings for the first few layers, because it's basically like if you slice a basketball, the slices are very thick. So you don't want those slices to be very thick on the bottom. You want them to be very thin so you can barely notice the slicing. As it goes up, it'll look like any other print, but we want to make sure that these bottom ones are very, very thin. So we'll slice it with the different settings on the bottom. It will increase the print time, and then we're going to speed it up as we go up. And then as we notice things like the chin, and where it's just the chin, we're going to slow it right back down, and we're going to have a real good time with it. All right, guys, thank you for tuning in with me today. It's been great having you. Ron, thanks for the advice. It's awesome having you guys come back around every time. Tomorrow I'll do a full Today in 3D. We're going to cover the last 3 days worth of 3D printing news. Got some good stuff out there. Joel Telling's always coming out with new stuff. All right, people, thank you so much. Let's go ahead and sign off. Print on, my friends. Print on.